Let's take a look at our requirements. We've got a calculation here, and I can see it mentions learning curve. This question looks like an outlier. Often there's a clue that when there's a little bit of extra narrative and it's not a calculation, often it ends up being an outlier, except that this one refers to the 50th unit. So I'm going to leave that just in case, because maybe there's something in the narrative that is important. Here's a calculation, another calculation there. And again, it's got that setup like before, but this one is an outlier. We're asked which two of the following statements are correct. Management accountant determined the correlation coefficient of data set related to total machine costs and machine hours was 0.9. We need to choose two of these. First one, 90% of the variation in machine costs from month to month is caused by a factor other than machine hours. I've seen questions like this in one format or another quite a lot. Again, this isn't something I'd be writing out in the exam. Correlation coefficient is 0.9. So the coefficient of determination equals 0.9 squared, which is 0.81. A coefficient of determination of 0.81 means 81% of the variations seen in the dependent variable can be explained by a change in the independent variable. And this says 19% of the variation in machine cost from month to month is caused by a factor other than machine hours. Machine hours would be the independent variable. Machine costs would be the dependent variable. If 81% is explained by or caused by machine hours, then 19% would be by another factor. The change in the x value explains 90% of the change in the y value. This is a common mistake. What that's doing is taking the 0.9, i.e. 90% correlation coefficient, but using the coefficient of determination to describe it. So that's not true. So make sure you're clear whether you're talking about the correlation coefficient or the coefficient of determination. The correlation between machine hours and total cost is strong. A 0.9 correlation coefficient is strong. An increase in machine hours of 90% will increase total costs 100%. That's just a nonsensical comment. So we've got our two answers there. So let's take a look at our narrative. Kent co-produces a range of consumer electronics and has launched a new media streaming device called the Streamster. The Streamster will be produced by the existing workforce on a new production line, and the production process will be similar to that of other products they produce. The following product information is available: product price, material and labour cost, fixed overheads, and profit. I've highlighted fixed overheads. That's an allocation because we're looking at on a unit basis. A common mistake that's made is students leave a fixed overhead cost in instead of treating it in the correct way. The cost and above did not consider the possible learning curve effect among the production workers. The production supervisor is confident that a 90% learning curve should apply and that a steady state of production will be reached at the 50th unit. That means when we hit 50 units, the learning curve stops. So the 50th, the 51st, 52nd, etc. will all take the same length of time as the 50th. It's given us the learning index of 0.152 and labour paid at $27.50 per hour. The marketing director expects demand for Streamster to be seasonal, has made the following projections for a seasonal variation. Q1 to Q4. It's got the trend equation here, where X is the quarter and Y is sales. This is the very hard to say multiplicative model. We know that because it's got percentages. The additive model will have actual numbers in dollars. Well, this is a learning curve question. What direct labour cost should be applied to the 50th unit of the Streamster after adjusting the time per unit for the learning curve? So we don't actually need the bottom bit for this part of the question, we just need the top bit. We don't get many formulae in this exam, but we do get the learning curve, which is here. Y equals AX to the B. Y is the cumulative average time to produce X units. Often easier just to think of it as the average time rather than tie yourself up in knots of thinking what's going on there. A is the time for the first unit. X is the cumulative number of units. B is the learning index and LR is the learning rate. We're given both here. We're given the learning rate as 90%, but we're given the learning index, so we don't need to do this calculation. This scenario where we have to work out a cost based on the learning rate happens quite often, and it's worth learning this process. We need to do a calculation for 50 units, and then we need to do one fewer. So if the steady state occurs at the 50th unit, we work out the total time taken for the first 50 units. We work out the total time taken for the first 49 units, and the difference must be the time taken for the 50th unit. That gives us time, and then we need to multiply by the hourly rate to find out how much it costs. So we're going to use y equals ax to the b. Again, I wouldn't write all of this out. So a little template here. We've got the figure for a, we've got x to the b, which will give us y. Then we multiply by the number of units, and that gives us the total time. Time for the first unit. We need a side calculation for this. For the first unit, the direct labour was 11 at 27.50 an hour. Means 0.4 hours was used. Next I need x to the b. Well, we're told b is minus 0.152. For my top row, x is 50. Now this is one of the frustrating things about this calculator, is I don't think you can do this calculation in a very simple way. Normally I would do 50 to the power of minus 0.152, but I think it never likes it. Yeah. So the workaround is, well, either you have a separate calculator, or you just have to remember a little bit of the maths here. Anything to the power of a negative is 1 over the same number. Let me write it out here. M to the power of negative n. So m to the power of minus n equals 1 over m to the power of n. So you have to use that in order to use this calculator. So we can't do x to the power of b when b is minus, but we can do x to the power of b using b as a positive, and then we use the reciprocal function, which is x to the minus 1, flips it upside down, and then we get our answer. So x is 50 to the power of 0.152, so that gives me 1 over x to the power of b, and then I use the reciprocal function there, and that gives me the x to the b. Now I think we have to be very careful with decimal places. In learning curves, we need 2 decimal places, so I'm actually not going to fill this column in. I'm going to multiply by a, because we need y equals ax to the b. This would be what would go in this column. That's 0.5177 goes there. Y is 0.2207. But then the next thing I would do is multiply by 50 to get the total time. So I think it's worth taking the calculation all the way to the end and keep a fair number of decimal places. We want 2, so I've gone for 5. And then we just do the same process again, but for x equal to 49. So 49 to the power of 0.152. Find the reciprocal of that. That's now x to the power of b, and multiply by 0.4. That's now given me the value of y. Multiply by 49. That gives me the total time. Now I need the difference in time. I don't clear my calculator. I've already got the bottom row in. If I subtract the top, but I'm going to ignore the negative. It's just because I've done the order of calculation back to front, but I think that's more efficient to do it that way rather than risk mistyping numbers. So the time difference is this many hours. I now need to multiply by the hourly rate, which is 27.50, and that gives me 5.15. That all rounds down. So 5.15 is the corrected cost for the labour rate. That's a little bit fiddly, a bit annoying that the calculator doesn't work like it should do. I assume it's the same on the actual exam platform. It could be one of the nuances of test reach that it doesn't quite work as well. But hopefully that workaround there will help you out. I accidentally clicked on this. We haven't actually answered this question. Which of the following statements is true about the cost of the 50th unit? After the first month of production, the production supervisor realised a 95% learning rate should have been used instead of 90%. What will happen then? Will it remain unchanged? Will it be lower, higher, or will it decrease after a certain number of units? Well, hopefully you can eliminate the top one and the bottom one. You just need to work out, is it lower or higher? Correct answer is higher. There are different ways to remember it. 95% is higher than 90, which means it will take longer than expected, which means it will cost more, so the cost is higher. And then the other way to think about it is to think about this table where we double, so we go from 1 to 2 to 4, and then just plug in some arbitrary figures. So let's say it took 100 hours for the first unit for both scenarios. With a 95% learning rate, it would take 95 on average for the first two, and 90 with a 90%. And then for 4, it would be 95% of this figure, or for this one, 90%. Well, you need to do 2 rows, but hopefully you'll see that it's taking longer here. The higher percentage learning rate is actually worse for progress. So it costs more because we're still using higher level of hours than we would here. What sales level is forecast for Q4 of year 2 of the stream stood to the nearest unit? Assume index number 1 refers to Q1 of year 1. This uses the bottom bit with this trend equation we're given down the bottom. There's 2 parts to a calculation like this. First, we need to use the trend equation to work out a value of y. Then we need to apply the seasonal variation. So y is 85,000 plus 2980 lots of x, and x indicates the quarter. And we're in Q4 of year 2, so that's 8. Using my calculator, that gives a value of y 108,840. But now we need to do the seasonal adjustment. If it's Q4, then it's 135%. So we multiply by 1.35, giving us 146,934. There were 2 questions in this mock that annoyed me. This was one of them. And I just want to go into this one a bit more. It's hard to know if you'd ever get a question like this with a seasonal variation where you've got to calculate an exact figure. And the answer I did in the working just now is the same answer that's given in the exam feedback, but it's not quite correct. And the thing is, with this system where you type in an exact number, if it's not quite correct, it's wrong. There's no variation. And what is often forgotten is when we're doing seasonal variations, we often have to make adjustments. When we're using this model, the multiplicative model or the additive model, we have to make adjustments. And with this model, what we must do is total these up, and that comes to 380. Now we've got 4 quarters, so what that should be, this should total 400. Similarly with additive, they should cancel out to nil. So we end up with a balancing figure. This one should be 20 higher, this should be 5 lower. And what we're then meant to do is recirculate that difference back across these. So this one was 5 under, so we should adjust each of these by -1 1/4. So the top one would be 28.75 and so on. With this method, we share it out across the 4 quarters, but it's done differently. It's done in this ratio, so we work out the difference, the 400 divided by the 380, and we adjust by this factor. And now these total 400, and that's what's meant to happen. So instead of multiplying by 1.35 as we did and as the model answer did, we should have multiplied by 1.42101. What we did is we took the value of y, we multiplied by 1.35 to give the figure that's in the box up here. What we should have multiplied by was 1.35 by 400 over 380, which gives quite a different answer. 154,000. And if we'd typed that in here, we'd have got it wrong based on the way this mock was set up. This is one of the subtleties of seasonal adjustments with the multiplicative method. If we've got 4 quarters, then it should add up to 4. If we had 8, it should add up to 8, and so on. With the additive, they should always cancel out over the year. Anyway, I've left the answer as it was in the model answer, but truly, if we did it properly, it would be this. This is a frustrating thing because it's not really clear what stance the examiner would take on this. Unless the examiner has somehow managed to code this so it can have both answers. I'm not sure if that's possible. What would I do in the exam? I would give the most correct answer. But to be honest, if you remember in this level of detail, these adjustments, you're probably going to get a pretty comfortable pass anyway. Anyway, it's a bit disappointing when we have a question where there's no narrative that we can put in. Had this been a section C question, then this working would have been shown and then would have scored the marks for it. But when you're just entering an answer in, it's definitely much more frustrating when there's a bit of a dilemma. The last few mocks I've seen have not done the adjustment, but I said at the opening of the section A question, the mocks aren't written by the examining team. I think the examining team would expect this as the proper answer. Anyway, I'll leave this one be and we'll move on, but just a bit of frustration around this one. In question 29, using regression analysis, what are the estimated fixed costs to the nearest dollar? The management accountant needs to calculate fixed costs related to an expensive item of production equipment that will be used in the new product. She's gathered the following information from the previous 12 months. Got the sum of machine hours, total cost for the year, variable cost per hour. The management accountants arrived at the results above using monthly totals, i.e. the spreadsheet contained 12 rows of data. We need to use regression analysis and work out the estimated fixed costs. So regression analysis is one of the ones that's given to us in the formula sheet. So we're given all 4 of these. The top 3 are all linked together. Y equals A plus BX, where this is A and this is B. This is the correlation coefficient we spoke about earlier. So the Y equals A plus BX, the way this links to fixed costs. So Y represents the total costs. A is the fixed costs. B is the variable cost per unit. And X is the number of units. So that's how this top equation relates to working out fixed or variable costs. We need to find the fixed costs. We need to find A. It tells us A is the sum of Y divided by N, and take away B times the sum of X divided by N. So sum of Y is the total cost for the year. We're given that up there. And we need to divide that by N, which is the number of data sets we have or lines of information. That's what this is telling us, the 12. And now we need B times the sum of X divided by N. B is the variable cost per unit, so that was 535, multiplied by the number of units. A unit in this question is a machine hour, also divided by 12. We can use our calculator for this. The way I would do this, I would do the first part. It's the 10,350,000 over 12. That gives me my left-hand side. And I subtract from that, and I use the brackets for the second bit. So it's 5.35 multiplied by 252,336, and that's divided by 12. Close the brackets. I get 750,000.2. Nearest dollar is 750. We've answered that one already. Check my navigator. That's all of section A and section B complete. And that's the end of this video. Next we'll be moving on to the section C questions. Thanks very much.